Every defensive round is a mechanical compromise, and nowhere is that trade-off more visible than in the head-to-head competition between Federal Premium HST and Speer Gold Dot. At identical price points between 90 cents and $1.30 per round, these two options force a choice between two distinct failure modes. The Federal Premium HST utilizes a deeply skived jacket and an internal post to achieve a signature six-pointed star expansion, setting the industry benchmark for terminal performance. However, this design remains susceptible to jacket and core separation when encountering hard barriers. Conversely, the Speer Gold Dot leverages Uni-Cor electrochemical bonding to fuse the jacket to the lead core, ensuring nearly 100% weight retention through those same barriers. The cost of this structural integrity is a less dramatic expansion diameter compared to the HST. You are not choosing between a superior round and an inferior one. You are choosing between a round optimized for maximum wound channel width and one engineered to maintain its mass through intermediate obstacles. This constant tension between expansion and barrier penetration defines the entire landscape of defensive ballistics. Understanding these mechanical trade-offs is the only way to select the right tool for your specific threat environment. The Federal Premium HST is the round every other self-defense cartridge gets measured against, not because of marketing, but because of what its geometry does under stress. The architecture starts with a deeply skived jacket, meaning the copper is pre-cut with longitudinal grooves before the bullet ever leaves the factory. Seated inside the hollow point cavity is an internal post. When the nose contacts tissue, hydraulic pressure drives fluid into the cavity. The post forces the skived petals outward, and the jacket peels back into a six-pointed star with consistent, repeatable geometry. That expansion pattern is not accidental. It is mechanically enforced by the post position and skive depth. The jacket and core are locked together through that same mechanical interference, not through chemical bonding. Federal relies on geometry, not metallurgy, to keep the projectile intact during expansion. The performance consequence of that design is a large, uniform frontal diameter that transfers energy efficiently into soft tissue and maintains enough residual mass to reach vital structures at standard service velocities. In ballistic gelatin, the HST produces some of the most consistent expansion data in the centerfire self-defense category. Law enforcement adoption across federal agencies is a downstream result of that consistency, not a cause of it. The structural vulnerability is specific and worth stating plainly. Because the jacket-core relationship is mechanical rather than bonded, hard barrier impacts, autoglass in particular, can generate enough lateral stress to separate the jacket from the core. When that happens, the core continues forward at reduced diameter, and the jacket tumbles away. Penetration depth after barrier transit drops, and the wound channel narrows. Against soft tissue with no intermediate barrier, this failure mode is essentially irrelevant. Against a vehicle windshield, it matters. At 90 cents to $1.30 per round, the HST sits at the same price tier as its closest competitor. That pricing makes the barrier vulnerability the only real decision variable for most users. For concealed carry in environments where vehicle glass is an unlikely intermediate barrier, the HST's expansion geometry and velocity-independent reliability make it the field baseline. That is, the standard every round in this comparison is working against. Same price point, different engineering philosophy, and the difference is not cosmetic. The Speer Gold Dot's defining mechanism is Uni-Cor, an electrochemical bonding process that fuses the copper jacket to the lead core molecule by molecule during manufacturing. The result is not a jacket pressed onto a core, it is a single, unified projectile. That distinction matters under barrier stress. When a gold dot transits autoglass or sheet steel, the jacket cannot separate from the core because there is no mechanical interface to fail. Weight retention approaches 100% through hard intermediate barriers, a figure that holds across documented law enforcement testing and independent ballistic evaluation. The trade-off is expansion diameter. Because the jacket and core move as one mass, The Gold Dot does not pedal outward as aggressively as the HST's deeply skived, post-driven design. The frontal diameter after expansion is measurably smaller. In soft tissue with no intermediate barrier, that narrower wound channel is a real performance difference, not a theoretical one. The Gold Dot is not the round that produces the most dramatic gelatin photographs. It is the round that produces the most consistent results after the bullet has already done something difficult. That distinction defines its use case. For duty environments where barriers are a realistic variable, vehicle glass, interior walls, layered clothing, the bonded construction eliminates the failure mode that the HST's geometry cannot fully prevent. The New York City Police Department and the French Gendarmerie have both standardized on Gold Dot for exactly this reason. The round's toughness is the mission-relevant variable in those contexts, not peak expansion diameter. Pricing runs 95 cents to $1.30 per round, overlapping the HST range entirely. The G2 variant, which uses a re-engineered hollow point cavity for improved velocity-independent expansion, is gaining adoption in agencies updating their duty loads. The field mechanics read, "If your threat environment includes hard barriers, Uni-Cor bonding solves a specific failure mode that geometry alone cannot. If it does not, you are paying for toughness you may never need, and accepting a narrower wound channel in exchange." If barriers are the mission, one round was engineered specifically for FBI protocol, at a recoil cost. The Hornady Critical Duty was not adapted for law enforcement use. It was built from the specification sheet outward to satisfy FBI testing protocols, which require reliable terminal performance, not in bare gelatin, but after the bullet has already defeated an intermediate barrier: auto glass, drywall, steel, layered clothing. That requirement exposes the core weakness of conventional hollow points. Barrier material packs the cavity and prevents hydraulic expansion, turning the round into a de facto full metal jacket at the moment it matters most. Hornady's mechanical answer is the FlexLock tip, a polymer plug seated inside the hollow point cavity. Against soft tissue, the plug acts as a wedge that initiates expansion. Against hard barriers, it physically prevents the cavity from filling with glass fragments or denim fiber. The plug is not a gimmick. It is the mechanism that keeps the expansion geometry functional after the bullet has already done something the Gold Dot's bonding was never designed to address. A tough interlocking jacket reinforces the structure through the deceleration spike of barrier impact, so the bullet that exits the barrier is still geometrically capable of expanding on schedule. The result is barrier-blind performance, consistent terminal behavior through glass, steel, and drywall that independent ballistic testing and law enforcement evaluation have documented repeatedly. The round earns that description mechanically, not as a marketing claim. The platform cost is real. Critical duty is a plus P load. That elevated pressure produces measurably higher felt recoil, and in subcompact or micro-compact pistols, that recoil signature becomes a control and reliability variable, not just a comfort issue. The round is optimized for full-size duty pistols. Running it in a compact carry gun is an engineering mismatch, not a preference. Pricing runs $1.20 to $1.60 per round, the highest in the centerfire group so far. The field mechanics read, "Critical duty is situationally optimal, not universally superior." If your platform is full size and your environment includes hard intermediate barriers, this is the correct engineering answer. If neither condition applies, you are absorbing recoil and cost for a capability the scenario will never demand. Maximum expansion looks decisive on paper. The mechanism tells a different story through barriers. The Winchester PDX1 Defender traces its lineage directly to the Ranger T-Series, and further back to the original Black Talon. The name changed, the engineering did not. The core design is a reverse taper jacket that peels into 6 sharp cutting pedals on impact. That geometry produces a massive frontal diameter and a wide, violent wound channel. The expansion is not incidental. It is the entire design objective, optimized deliberately and without compromise. That optimization is also the constraint. The same pedal geometry that maximizes wound channel diameter requires the bullet to shed velocity rapidly as it expands. In bare gelatin, that trade-off is acceptable. Penetration typically reaches the lower end of the 12 to 18-inch window. Through a hard intermediate barrier, the math changes. The petals deform or partially deploy on barrier contact, and the bullet arrives in tissue with a compromised geometry and reduced remaining velocity. Penetration depth drops. Bonded rounds like the Gold Dot retain jacket core integrity through that same barrier impact and arrive with more mass and more consistent geometry. The PDX1's aggressive expansion architecture has no equivalent of Uni-Cor bonding to absorb that deceleration spike. Barrier performance is the documented weak point. Against glass, steel, or dense clothing layers, the PDX1 underperforms relative to bonded or solid copper designs. That is not a defect. It is the consequence of optimizing one variable at the expense of another. The round is mechanically coherent for its purpose. That purpose is soft tissue terminal performance in environments where intermediate barriers are unlikely. Pricing runs $1.10 to $1.50 per round, consistent with the centerfire group. The field mechanics read: the PDX1 is the correct round if your threat model does not include hard barriers and you want maximum wound channel in tissue. If barriers are a realistic variable in your environment, the expansion advantage disappears at the moment it matters most, and a bonded design is the better engineering match. Shifting from centerfire, the CCI Mini Mag 36-grain hollow point represents the established baseline for rimfire ammunition, where the entire performance ceiling drops and reliability takes on a different mechanical definition. This 36-grain copper-plated hollow point, when fired from a rifle, achieves velocities around 1,260 feet per second. This kinetic energy typically results in 10 to 12 inches of penetration in ballistic gel, alongside 50 to 70% expansion, yielding a final diameter between 0.33 and 0.37 inches. The clean-burning propellant is a key feature, minimizing residue and promoting reliable function in semi-automatic firearms. At a cost of 10 to 14 cents per round, it stands as the most affordable, reliable option available. However, these performance metrics are critically dependent on barrel length. The stated velocity and expansion are achieved from a rifle. When fired from the shorter barrels common in rimfire handguns, the bullet's velocity drops significantly. This reduction in speed directly compromises the hollow point's ability to expand reliably, and consequently, its penetration depth often falls below the FBI's minimum 12-inch standard. Unlike centerfire rounds engineered to perform across varied barrel lengths, the Mini Mag's mechanism requires sufficient velocity to initiate and sustain expansion, a condition often unmet in compact rimfire platforms. This inherent velocity dependence is the primary mechanical constraint. Consequently, the CCI Mini Mag is revered for its consistent function and affordability, making it an excellent choice for training, plinking, small game hunting, and pest control. Its widespread availability and reputation for cycling reliably in diverse firearms solidify its position as the go-to rimfire round. For self-defense applications, however, its variable terminal performance in short barrels means it cannot be considered a direct equivalent to centerfire options. Its reliability is in function, not consistent expansion or deep penetration from every platform. This distinction is crucial. In rimfire, you are often trading raw power and consistent terminal ballistics for lower cost and recoil, fundamentally redefining what effective means. The Federal Punch 29-grain flat nose represents a radical departure from traditional defensive ammunition design. While most rounds prioritize expansion to create a wider wound channel, this .22 caliber rimfire cartridge utilizes a solid lead core with a flat nose profile specifically engineered to avoid mushrooming. From a 2-inch barrel, it achieves a muzzle velocity of 1,070 feet per second. This specific configuration is purpose-built for ultra-compact handguns, where barrel length is the primary limiting factor for terminal ballistics. At 20 to 25 cents per round, it is priced as a premium defensive rimfire option, reflecting its specialized engineering. The performance implications of this design are a direct response to the mechanical failures of rimfire hollow points in short barrels. In a sub-3-inch barrel, standard hollow points often lack the velocity required to expand, resulting in unpredictable tumbling or shallow penetration. Federal engineers solved this by abandoning expansion entirely. By utilizing a lightweight 29-grain projectile with a flat face, the round maintains a straight, stable path through the target. This mechanical decision allows the projectile to achieve 12 to 15 inches of penetration in ballistic media, consistently meeting the Federal Bureau of Investigation's minimum benchmark for defensive ammunition. It is a counterintuitive solution. By refusing to expand, the round ensures it reaches the depth necessary to strike vital structures. Practically, the Federal Punch is the definitive choice for those carrying small-frame .22 caliber handguns for self-defense. It transforms a platform traditionally viewed as underpowered into one that meets professional penetration standards. The flat-nose design is not a compromise or a budget-driven omission. It is a deliberate engineering answer to the physics of low-velocity ballistics. In this showdown of mechanisms, the Punch proves that the most effective round is not always the one with the most aggressive expansion, but the one that best matches the constraints of the firearm. It resolves the tension between expansion and penetration by prioritizing the variable that matters most in a deep concealment scenario: reaching the target. Which brings us to the final verdict on matching engineering to your specific environment. Our journey through defensive ammunition reveals a consistent truth. Every design choice carries a mechanical cost. From the HST's expansion to Gold Dot's bonding and Critical Duty's barrier-blind performance, each excels by sacrificing elsewhere. The Winchester PDX1 showed maximum expansion can limit penetration. Ultimately, the Federal Punch's deliberate flat-nose design for short-barrel .22 LR platforms perfectly encapsulates this. It abandons expansion entirely, yet achieves FBI standard penetration where hollow points fail. The verdict is clear. There is no single best round. Instead, effective self-defense demands matching the ammunition's precise engineering to your specific firearm, its barrel length, and your intended use case. This ensures reliability and terminal performance where it truly counts.